everyone is talking about the microservices, and everyone is talking about micro frontends. The question that comes in my mind is that being in a Hybris experience, how these gonna fit in within the Hybris, and can they go hand in hand, or what is the capability that we can utilize, or what is the features of the Hybris that we can use as a when we talk about the microservices or the micro frontends. So we gonna talk about those capabilities in order to understand that, how we can build the MFEs or the microservices using the Hybris. So that will be the primary goal for our talk today. So that's how we can cover it. I want to talk about how the Hybris technology has been evolved. And I would talk not like Hybris in nutshell, I would talk about that Hybris technology evolvement in alignment with the service-based or the microservice-based. If you remember, I guess if you might be old enough to understand that in 2008 or 9, I guess, I started working with the Hybris. So that point in time, Hybris 3.x was there. And this was the first, one of the first project which came to my organization, and we were the first team which actually started, working on those things. So, the funny part was that, in the whole this commerce application, there was only one product which was on a selling side. And so for only one product, we have created a Hybris 3.0. So putting that apart, at 3.x, the Hybris was kind of complete MVC system. There was a controller and a front-end layer, which is handled by the JSPs. Then there was a middle layer, which talks about services, which is integrated very tightly coupled with the Java layer, which was the ORM layer for the Hybris. And it was completely based on the MVC architecture of the Spring based. It was a kind of monolithic architecture. And if you see the 3.x or the 4.x, both were similar kind of things with a different set of features which had been introduced. After 4.x, there's a major change which happens from the architectural perspective was the introduction of the service layer. So the main problem which had been observed in the earlier version was that your business layer was tightly coupled with your ORM layer. And hence, a lot of business understanding or business implementation goes to the Java layer, which wasn't the idea at that point of time. And considering the complexity in the Java layer and the objective of the Java layer or the ORM layer has been basically misunderstood and mismanaged. And that's why we come up with that service layer where we introduce the models, model services, and all the infrastructural services to support this service layer. At that point, I'm sure remember we have introduced the contracts that how your facade or the controller will interact with that Java layer. It has to be through the model. You cannot send the models to the front-end layer. So these are things which have been established at that time. So after 5.x, the major change which I could see in OCC there. If you remember, on early of 2010, you would see that there was a lot of front-end evolution has started happening. So we could see that any front-end requires to be managed on multiple kind of devices, and the complexity of the front-end systems and the requirements in the front-end layers had been changed a lot, and a lot of complex requirements have started coming to the front-end side. And that's where you see that a lot of emergence of the new technologies and the APIs and that has started emerging only for the front-end. So architect and Hybris, and they started to see that, since we have a lot of complex things, why don't we decouple it? And that's where they started the OCC V1. So OCC was nothing but providing all the backend services as APIs so that front-end layer or any other system could take care about these services from the backend side, and for front-end they can manage that themselves. So you see that the OCC has been came in the picture, and then we started working on that headless commerce at the point in time. Now, if we see the biggest challenge for the OCC was that it was stateful. Considering stateful, there's still a lot of dependency between the your front end and back end. It was tightly coupled. And let's say if you wanted to serve these services to the multiple places, let's say I wanted to serve this to my website, then I want to serve to my app, then I wanted to serve to my aggregator or some of the third parties. May not be, and these OCC version 1 wasn't very great to handle those kind of scenarios, and that's where Hybris introduced the OCC version 2. So the major change for the OCC V1 to V2 was about the state. So in OCC 1, this was stateful. OCC 2, V2 was stateless. So after the introduction of stateless, now every service got independent with the other services, and that's where we started to see complete headless commerce. And I guess 3 years back, we have completed the complete headless commerce DBT system. I mean, we have done for the Australian client, which was a very giant, and then we have completed in a 2 years span of time. So OCC V2 was a big game changer when we talk about the headless commerce. So now we have the services. So what we have done till now is that we have MVC. From MVC, we have decoupled the front end, and we got all our backend as a services. Now, the other challenge which I've seen for the deployment side. So if you see that in deployment side, it was scalable. We have emergence of the clouds technologies, and with the emergence of cloud, we don't have the proper cloud mechanism within the Hybris. And we don't have a capability within the Hybris infrastructure services which might handle the clouds. And that's where the Hybris had been changed in a way so that it could handle the different cloud features. So you see that, if you see the SAP Commerce CCV2, you see that there's a lots of capability which came up. You could deploy your API services differently. You could deploy your web services or the backend services differently. You can deploy your back office differently, and you can create own domain for their back office systems. So you could do all these things once the CCV2 came in the project. So now we could see that Hybris has a decoupled front end, Hybris has a decoupled deployment side, and then it has a bunch of services which takes care about its business logic. So basically all three had been decoupled, and this has been done the way the requirements comes, the complexity of the architecture comes in. And so how? So this is the evolution which I could see from my own experience in the past, I guess, 12 years. So now we wanted to see that how this is aligned with the microservices. So let's talk about something about microservice architecture before moving that how the Hybris is good at the microservices. When we start the microservice architecture, we need to understand that why it has emerged. What was the reason or the issue in the previous architecture, and because of that, we have to create or evolve this architecture. So you see that in a monolithic architecture, if you wanted to scale it down or if you wanted to maintain it, it's difficult. Why it's difficult? Because if you see in monolithic architecture, every functionality, everything is in the same code base. The deployment is same. So if you wanted to change a small feature of the whole architecture, you have to pick the whole bunch of code. You fix that information, then you do a regression testing, you do a complete testing, and you make sure that the things are working fine. Then all you will be able to deploy. And obviously, if the scale of code is heavy, your deployment cycle would not be fast. The deployment has to take a lot of time. There could be a multiple range of deployment cycle for every release. So these kind of problems that we started seeing in the monolithic. The other time could be your development cycle, time to market. So if you talk about the development cycle, obviously, if there's a more complex system, that change might take some more time to do it. And then once you have the complex system, obviously the release time takes a lot of time because there's a longer testing cycle, there's a longer regression cycle, and obviously once you have all those things takes time. You cannot basically release a feature in a day or two. That would always take a time. And then the third things, which is my favorite, is the low resilience. Think about it. You have a very big system, and in the whole big system, if there's a small component fails, what happens? In a monolithic, your whole system will start failing in. Why? Just take a small example. Let's say you are calling a third-party web services, and for third-party web services, you have a time, let's say 10 minutes. So it generally responds, let's say, in some milliseconds, but somehow you put up your timeout for 5 minutes or 10 minutes or 2 minutes, whatever you can think of. Now, for a typical hybrid system, you might have the 200 HTTP threads that might be serving for each of the request that comes in. So consider a scenario that, one thread, stuck because the third party is not available. So it has to wait for 2 minutes or 10 minutes. On the same time, if another request comes in, the another thread start waiting in. And let's say within a 10 seconds, there's a 200 request comes in, then basically all threads start waiting it and your JMA will collapse. Or your server will not be able to serve any of the request. So this could be a very small example, So the problem in the whole architecture, if you see in the larger scope, a small component can fail the whole system. So as an architecture, we wanted to mitigate these problems, which was introduced in Monolithic one. So let's see that what are the options that we have. If you see that the option that we might have is one is a service-oriented architecture. So probably what we can do in that against a monolithic, we could create multiple services which might be isolated with each other or the loosely coupled between each other, and then they can serve the purpose. Now the SOA can easy to maintain or easy to develop, but time to market or the resilience might result in the same because the deployment is also in the same system. Another options could be your event-driven architecture. So what we can do is that we could break our system into multiple mid-level segments, and then these segments start talking with each other based on the events. That could be another possibility. And the other possibility could be that your microservice architecture. This lets you break your system to the smallest level of independent workable modules, and then it could deploy and delivered separately. And hence, if it is loosely coupled, probably it can serve the better purpose. So out of these three, let's see in detail that how the microservice architecture will solve the problem of your monolithic architecture. Microservice architecture is basically, talks about that, how you are breaking your whole complexity, whole complex application to the smallest multiple independent modules or the services. And these services can act independently. It could deploy independently. It might have their own DBs. It might be interacting with the other services in order to complete the functionality, but they could develop independently. So this is the basics of microservice architecture that need to broken down, work independently, managed by independently, released by independently, and the interaction between the microservices would always be loosely coupled. So now, if you see that microservices always designed to do a specific task or a specific business function, or set of business functions, that could be led by independent team. So, so for example, let's say we have one commerce system, and if let's say we wanted to break it into smaller pieces, we can think about maybe we wanted to break it from the business wise, or we might wanted to break based on what is the technology stack that we have. And usually it happens by the business wise. So, business is something which is driving our system. So breaking by the business wise makes sense, but it has to align with the technology as well. No. So each system that has own precedent based on that it could be broken. Now, the third, which is the most important point for the microservices, could be that it has to be loosely coupled. So, we have to think about the principle of loose coupling. That means microservice itself could be very cumbersome, which could be tightly coupled between the component within itself. But when the things comes to talk to interaction between the microservices within each other, then it has to be loosely coupled. And when we talk about the loosely coupled, that means, if something fails, something is not available, or something which is, let's say if microservices is not responding appropriately or giving the error scenario, it has to be handled. And the calling client of the microservice should not be broken or stopped because the other microservice is not working correctly or is not available, or maybe it's not behaving perfectly. That's the principle of loose coupling. So we have to make sure that these microservices are loosely coupled as well. So these are the basically, we should think about while creating the microservice. So if I wanted to put the attention to the picture, so you see that there's below the line, there are 3 microservices which are talking to their own DB, but there could be microservices which could be dependent on the other microservices. And they might be interacting with the other microservices just to fulfill the business functionality. So we have to think in that perspective. Now, I wanted to put you guys in the perspective that how Hybris could act as a microservice. We know that Hybris has a OCC version 2 functionality. That means it could act as a setup provider, as a service, as a microservice. If you club into the multiple functionalities. Now, Hybris can also be deployed on the CCV2, considering that this might have multiple deployment based on a different functionality. So we could have a deployment where I might be exposing only that checkout functionality in the API layer, and there could be another deployment of Hybris CCV2 where I could be exposing only to the product services, and this could be managed at the endpoint. So Hybris can act as a microservice at that logical level, but on a physical level, it's difficult because Hybris is still using the same cluster, Hybris is still be using a same database. So that's how this Hybris as a microservice sustained. Guys, if you have any other thoughts, feel free to put it down on the chat, and I'd be love to hear from you guys. Now, what we have understood is that we have one monolithic system like Hybris 3.x or 4.x, and that got a problem. And that problem has been we are able to solve using a microservices architecture. Now, the problem is that the way we have got a complexity in the front-end side, problem that we have faced in the front-end, we have also started seeing the same problem in the front-end too. And once we started seeing those problems, we need to solve as an architect group. And that's where we came up with the concept of the micro front-end. So micro front-end is nothing but your twin brothers of the microservices. You can say that. So if I wanted to bring your attention to the right side of diagram, you see that, so MFE is best suited when it works with microservices. So you see that, there's a multiple microservices which has been exposed. You can see that service X and service Y, where service X is a part of one or multiple microservices, and service Y, let's have a single microservice. Now, when you have microservices, it's always better to have one layer on top of it, which could become a composition layer, which could handle by, let's say, API gateway, or by your Azure service, maybe the GraphQL, or you could create your that BFF layer with any other different technology. That's completely up to you. And then the specific front-end or the MFE will talk to their respective microservices in order to provide the functionality. So see, each micro front-end and each microservices has been, taken care of by the different set of teams. And then there's a functional backlogs which has been served within the team so that they can work independently on those backlogs. So this is the way, the development start working independently. And on the same time, they might have a different repository by itself. They can work on the different teams, And then you also would need a one layer where you'll basically assemble all these micro frontends, and you might use the CMS layer to assemble the pages or the view that will be served to the customer. So so this is the MFEs that on a high level that we can think about that they can probably solve the problem that we have in hand in the front end side. Let's go in detail that, what are the benefits, what are the don't and do's, what all we need to think when we deal with the micro front ends. So let's see that what is the benefit that we're going to have it once we start using the MFAs. So the first thing is code scalability. So we have a complex front end. And let's say if we are using MFE, obviously there would be a small chunk of code that need to be handled in the one place. And hence, tomorrow, if you wanted to fix anything, or you wanted to adopt a new feature, or you wanted to refactor the code because of so-and-so region, that would be very easy if we have the MFEs in the place, and that would be handled by the different teams. The other factor could be reusability, where each MFE might be providing one or multiple components, and these components can be reused in the different part of the page whenever it is required. So reusability can be another point that would be greatly benefited in the system. Then the third things come with the independent development. That means, since your different MFEs has been worked by the different teams, that multiple development work can go hand in hand. And since the MFEs is always loosely coupled within each other, there will not have a multiple dependency, and hence the release process might be very smooth and very quick. The other benefits could be agility. Agility means that let's say tomorrow if the business comes and asks you that, okay, hey, I'm there, and that's a very critical feature that we want to release as soon as possible, then how we can handle those things. And then since we have the different teams which is concentrated on the smallest section of the requirements for the front end side, that would be very easy to handle in those teams. And obviously, once considering that we have a less code, it could be developed easily, and then it could be released easily because that's an independent release, irrespective of what the other teams are doing, because there's no interdependencies too. The last option could be the scalability. That means since every micro frontend has been deployed independently in the cloud, let's say if I wanted to only scale my specific functionality, let's say I wanted to scale only the features which is there for, let's say, first, I could scale easily because that's the concentrated components or the micro frontend deployed in a different place. So I just wanted to scale those things. I don't need to scale everything in the functionality. So that could be easy. So these are some of the benefits that you could see while using MFEs. Now, the question comes for our mind is that, what is the best suited technologies for the micro frontend? So that's the very debatable topic. You might say that, React is great on this thing, or you can come and say that, okay, Node.js or GraphQL is a very great technologies when we wanted to use it as a micro frontend. So here, I'm not going to talk about any other technologies. Rather, I would talk about that what are the factors that will influence your choice of the functional, your choice of the technologies for the MFEs. So the choices, the factors can be that how much your technology is scalable. That means that tomorrow, if I have a lot of complexity in my components or in my functionality for which I'm managing the MFEs, how much it is scalable. That could be your compatibility. That means I have MFEs with the S technology in the MFE side. Now, in the backend side, we have a different technology. Then I need to understand that how these technologies are compacted. Are they aligned with each other, or they contradict each other? If they contradict, obviously we have to do a lot of customization to support the other technology where I'm interacting with. And hence my development cycle, my cost, my management, everything goes on a higher side. So we have to think that, if my technologies, which I've chosen for my MFE, is basically aligned with the other MFEs, the security technology tool that we are handling, the BSS layer that we are handling with the different technologies, and the microservices which we are handling. So we have to think about that. What is the compatibility level of the technology chosen by us? The other thing would be security. So we have to think that the technology chosen has to have that proper components to handle the security. So let's say that if we wanted to handle the authorization and authentication, then we have to see that if our technology choice supports these things by default itself. If we have to create these security considerations by scratch, obviously the cost will go away, will be a lot. Then this is my favorite, development team skill. So let's say if I have an existing team, and if that team doesn't understand certain technology, then there's no point of having those technologies for the development. And asking the teams to go ahead for the next technologies, which might be difficult for people to understand, to get expertise, and then support in future. And the other thing could be cost and the performance. More required thing could be your community support. So if you pick up a technology which doesn't have any community support, so tomorrow if you wanted to add any feature, or maybe wanted to add some security patch, or you might wanted to see a certain change behavior within technology, and you wanted to handle it, why this is happening, probably you'll not be able to do that until you don't have the proper community support for a technology choice. So basically, if you see that, if you consider all these factors while you are choosing a technology choice for your MFE, probably, you might end up having a right technologies based on your complexity of system, your ecosystem of technologies in your organization. So you can think about. Now, guys, if you think that there is a certain other factors too that might affect, feel free to write it down. I would love to see those things. Moving to the next. While dealing with MFEs, what are the best practices that we need to consider for the development, for the management, for the maintenance, and for monitoring? The very first thing, which is the basis, divide your application to logical domain. So obviously, divide it into logical domains, into the small domains. Now, don't do it too small, and neither don't make it so big so that could be considered a monolithic, but don't make it too small so that the management of handling a multiple independent component would be too much. Now, the other could be your consistent UI system. Your design has to be very consistent, look and feel wise, so that if let's say a customer comes in, he should not be seeing the two different components with a different designs on the front end. Now, the use of event-driven architecture, that's my favorite. Whenever we're dealing with the micro frontends or the microservices, always think for the event communication, event-based communication, not like, general REST-based communication or asynchronous communication. When I say event-driven, that means, whenever anything happens in the system, or let's say in case of our case, MFE, raise event and the continue. And hence, the other system will not have the hard dependencies. And then failure of your system would be very, very less. So whenever you design a system, whenever you communicate between the other systems, make sure that you have a event-based communication wherever it is possible, rather than the synchronous communication where the thread will wait, where your system will wait until you don't get a response, and that will create the hard dependency, and the chances of failure would be more. Now, the other part could be your shared data layer. Let's say if you wanted to have a consistent front-end experience, you might want it to put one CSS file. Now, you can keep the CSS file in a shared data layer so that every MFEs can share the same thing. And similarly, you could do all the other components which could be common across all the MFEs, and you could put in a shared location so that it could be shared between all the MFEs to give the right impression to the customer. Then that could be a prioritized testing and automation. That's the benefit for everyone. In case of MFEs, you have to test individually and collectively in the context too. So you should have to think for the automations, and you have to prioritize the testing side too. Then use a micro. That's the by default. So whenever you're dealing with MFEs, you are creating MFE because there's a complexity in the front end, and such a complex system there is a best practice that in the backend side also we must have the microservices to give the right or effective output, and hence it's preferred to use the microservice. Then implement the monitoring logging. That's the basis for any other system. And then use the version strategy. Yeah, this is my favorite. Why? Because that, since every MFE would be released by different teams. So that means, so let's say the other two MFEs had a dependency on my MFE, then there'd be a problem because I have to inform them that, hey, I'm changing this and this to the release on so and so date. So make sure that you are available, you are ready. To avoid these problems, whenever you make the versioning right versioning strategy, and your release process goes very smooth and without any hassle. So how it could be done that, whenever you release a next version of your MFEs, make sure that you are basically backward compatible to the previous version. Let's say if you have released the next version and then after somebody calls you the previous version, you should be able to serve those requests. And once you do that, the release process will be hassleless. So these are the best practices, guys. If you think that there's some more, feel free to ping in. Yeah, let's quickly talk about that. What is a micro frontend do's and don'ts. So when we talk about that, what we should do, prioritize decoupling that we have talked about earlier. Security, yes, security is much more important now because everything is deployed independently. It's not within the container, within that single JVM. So, and then the other MFEs are interacting with each other and to the microservices over the network, and hence we have to put the right mechanism for authentication, authorizations, data encryption layers, and all those things. Consistent UI shared data layer that is understood. Yeah, communication protocols. So this is important one because whenever we communicate between the other components over the net, we have to be aligned with that. What is our holistic approach? So let's say if you say that we are talking to the REST whenever there's a synchronous communication, and we are talking with that message queues whenever there's the event-to-event communication, then we have to stick with the same technology and same stack rather than thinking and using own things, because that will complicate your security, your infrastructure layers. You have to stick with the organization standards. Prior testing automation, that is anyways understood and required for every front ends. The other thing is the version strategy, which is we just talk about that. The version strategy is really required to manage it, because if you don't put the right version strategy and we don't make our every release to be a backward compatible, the chances are that a lot of failures, and then we have to avoid those things. So these are the tools that we have to stick whenever we deal with the micro frontiers. Now, what we should not do. So that is more important than do. So what we should not do is that, don't overuse the shared library. So shared library is to then give the consistent, let's say, experience to the customer. But we should not overuse the same things. So let's say all MFE is using the same thing, and we put all those libraries in a shared places. This will basically complicate the whole architecture, and then you basically end up having dependencies either on the shared location or you will end up having a lot of dependency between each other too. And hence, use it, but don't overuse it. Don't implement the shared state. Yes. This is basically comes with that, that our MFE has to be a stateful or stateless. I would prefer the stateless and let the state to be managed in that aggregation layer that is talking to the different MFEs. But let's say that the complications and you wanted to maintain a state, then at least don't share the state with other MFEs. Then the performance, obviously performance is always a major factor because you are dealing with the front ends, and front end directly impact the customer experience for your product. So if you are having a performance issue, that means you are deteriorating the experience of the customer, and that will directly impact your business too. Now, the scalability, don't neglect it, because we have to make sure that what is the future load that we foresee in our MFEs, and then based on those things, we have to think that what is the scalability that we have to maintain, and that's a feature that we have always need to consider on a client side. Yeah. Now, don't create an overly complex micro frontends. So this is the one I'm saying that I started earlier too, that whenever we are dividing or creating MFEs, don't create too small so that the overhead of managing or the communication between micro frontends would be too much, which will overwhelm your architecture. And don't create so less so that every other micro frontend can become as a complex system altogether. So make sure that, as your system grows on a complexity side, try to break again into the multiple pieces whenever it is possible. And make sure that you have that microservices, your micro frontends at the optimal level, so that it's not too complex or too little to have maintainability issues. Now, documentations, yes, in the standard process, they have to have the right documentation and lots of documentation, because if you don't have the right documentation, the future management would be a very, very difficult. And now this is a standard process for monitoring and analyzing performance. So now consider that you have a one monolithic system. So probably the one dashboard will suffice your purpose, or the 2 or 3 log files will suffice your purpose. But consider a scenario where you have, let's say, 10 or 20 different MFEs, which are talking to the 50 different microservices. Then, and everything has been deployed independently. That means you have to think to monitor more than 200 different components, DBs, networks, security. There's a lot of things to monitor. So you have to spend a lot of things when you talk about the monitoring and the performance on top of what we have for the monolithic architecture. So these are something that we have to avoid when we're dealing with MFEs. So yeah, so till now, what we have understood that MFEs are great. They can solve any other problem that we have seen in our systems, and everything is good about it. Now, I wanted to draw your attention on what is the problem that you could see when you use that MFEs. So if you see these problems, probably try to avoid the MFEs, or maybe think the alternatives. The first problem could be complexity. So MFEs takes out complexity of the code, but it brings the complexity of the architecture. If you see in the monolithic, you have only one deployment, one physical architecture, one ways to scale up and scale down. But in the micro frontends, you have multiple components which have been deployed, which has been scalable, which has a security measures in place, which have a different network measures in place. There are lots of complex ways to monitor these things. So the complexity increases. So make sure that you have a right candidate to go ahead for the micro frontend. Blindly don't start using micro frontends or MFEs for every system. The other good things could be your technical skills, because micro frontend requires specific technical skills to expertise in a different mindset altogether, so that you could succeed and you'll be able to achieve the objectives of MFE. So make sure that you have the right technical skills within the team. And now the integrations would be more in case of the MFEs. So make sure that would be the challenge that can come up with you, when there's an integration, that will be network hopping, there'll be a chances of failures, that is a resilience problem. So you need to make sure that you have an optimum level of integrations between the microservices and the MFEs. Now testing. So testing could be challenged because in a conventional system, we basically can test from the front end, and that front end calls go at till the backend system and DB side to test everything in place. But in the case of MFE, you have to test all the interactions. You have to test as a unit as well as you have to test all the interaction between the different microservices and the different MFAs within a group, and then you have to see in the front end that how the things is happening. So testing will become complex and challenged. The other problem could be a performance because you have now more network hopping, more network interactions, versioning problem. So versioning, again, it's a good thing to have it because you are able to go to market fast. But on the same time, whenever you are making releases, you have to make sure that there's a proper versioning, there's a proper backward compatibility, so that your systems is not basically breaking the whole ecosystem. Then there's the security challenge. Why? Because that every interaction is over the network. So proper security has to be in place. Otherwise, there could be security incidents. Now, the maintenance, I talked about earlier that the maintenance would be more because there are multiple systems, multiple deployments, multiple interactions, multiple services which have been exposed, and multiple interactions within the system. And then the cost. Cost could be the case because it requires more architectural governance. It might need specific technology that you might want to use it in case of the MFE. So the cost might be more. So this is basically, now we have learned about that, what is the MFEs, could be there, and what the purpose can serve, what we should do, what we should not do, and where it could be the best fitment. So now again, we'll revisit that, how this MFE fits in the Hybris. Let me conclude from my point of view. I might be right, might be wrong, that I'll leave it to you guys. The way I see the evolution of front-end code in that Hybris system, it's more over the monolithic. We don't have a services. We don't have the code which is aligned with the services or the modular approach. So that's where I see that maybe that Hybris front-end layer is not ready for that MFE side. And I believe at least now they haven't provided any of the capability which could lead us to override them or change them so that they could act as an MFE. And hence, I would prefer that, let's say, if we have a too complex front-end requirements, feel free to have a different technology for the Hybris used in the MFEs and use Hybris as a microservices, as we have talked about earlier.